Hey everybody, this is Mr. Munson, and we're in Unit G6, Similar Figures. And so this section we're looking at here is called G.6.2, Similar Figures and Their Relationships. All right, so obviously if you look at these two pictures, there's a father and his son and a mom and her daughter. And these figures are similar, right? A dad and his son is not congruent to his son, right? And a mom can't be congruent to her daughter, but they could be similar. And there's likenesses and other things that are going on that make them similar. Now, when we're going to be looking at figures like polygons, rectangles, pentagons and things like that, and we're going to want to determine if they're similar. And if they are similar, then we might need to use some basic math to find some missing sides and missing angles. Let's get started. Now let's look at these two figures, and let me first of all put it on pause and add some information I needed. All right, let's first of all start off by of course, writing our title and our date there. But let's look at these complicated six-sided figures here with a lot of congruent angle marks and things like that. Now, I want to first of all talk about the definition of similar polygons. So there's going to be basically three ideas that you have to check for to see if polygons are similar. One is, first of all, does it have the same number of sides? We can't go any further if one's a triangle and another one is a hexagon. So let's start with counting the sides, and of course these both have 6 sides, so we know that they're similar at that step. Now, we're not fully convinced that they're similar until we do two more very important steps. One is corresponding angles are congruent. Okay, so what we have to do is go through and verify, are the corresponding angles congruent? And let me show you what I mean. So you go to one of the figures and you say, okay, here's A, and here's a single struck angle that's marked with a single struck over here. So whatever this value is, there's an angle over here that matches it. Now go to the right of it, and there's a double struck angle. And if this is any hopes of these figures being similar, if I go to the right, I should see a double struck angle, and I do. And I just continue to check that process as I go around, that they have similar congruent marks all the way through it. Okay, now not to make this any complicated, but it could actually, in this direction, it goes clockwise. As I check it, it might actually unfold going counterclockwise as long as the next one in succession is the one in the next succession over here. Okay, so you first of all check to see if the corresponding angles are congruent, and they are. If any one of these is out of place, maybe between the 3-struck and the single struck angles on this one is this angle instead, but over here between the 3-struck and the single struck is some other angle like this one, then that makes an error and we can't check it any further. Okay, the next step is to check to see if the sides are proportional. And what that's saying is this: when I take the corresponding sides and write ratios between them, these fractions have to all equal the same thing. Now keep in mind, they might not look the same. Maybe between two sides, over on this drawing, there's a 1 here, and this is between the single struck and double struck, so I'll go over here. Suppose there's a 1 here, and its corresponding side would be here, and that's a 2. So I'd write a ratio between them, right? But I might write a ratio between another set of corresponding sides, such as this one between the double struck and the triple struck. So I would come over here, double struck to triple struck. If I saw a 5 here and a 10 there, they might look like different numbers, but once we reduce the ratio, right, it becomes 1/2. And so they might not even look right. Right? We might check two sides and see one says 7.2 and another one says 14.4. And so those might not look the same, but once they're reduced, it turns out that that's 1/2. And so they all ended up being the same fractional amount. So if we were checking to see if some figures are similar, we would want to, first of all, check to see if it has the same number of sides. But most importantly, we would want to check, are the corresponding angles congruent? And then are the sides proportional? All right, let's talk about a concept called scale factor. And again, this is in your vocabulary words, so you should make sure you go back and review that if you need to. A scale factor is simply a ratio between any two corresponding sides. So I use my similarity statement here, notice that it has a wavy sign. It looks like this in bigness, right? It's not a congruent symbol, it's a similar sign. So I'm told that these figures are similar. That means that I can write a scale factor. If two figures are not similar, I don't have any business writing a scale factor. Scale factor gives us an idea if a thing is growing, it's getting bigger left to right, or if it's getting smaller. Okay, so looking at this, I see AB up here has a number on it, right? AB has a number on it. So let me go find its partner and see if it has a number so I can write a ratio, EF. And sure enough, it does. So I could write the ratio 4 to 5. Now I could also have written the ratio 5 to 4. So typically we talk about things going from left to right, growing, right? If this was the original, and then this is the copy of it, and we'll talk about that later. This is the original, this is a copy, then it grew. If this one's the original and this is the copy, then it shrunk. Now looking at these two scale factors, one gives you an impression of something growing and something decreasing. Something like this where it's 4 over 5 is telling you, hey, the scale factor is two items that are similar and they're shrinking. One is shrinking, right? The copy of the original is shrinking. This one is growing. This is a growing ratio. Okay, but that's a scale factor and how you simply do it. Now, sometimes we go to write a scale factor and the information's not there. So let's go write a scale factor between 6, which is BC. Now, BC, whoops, let's get my arrow here. BC, if you look at the similarity statement, BC is the two middle ones, right? BC. So it corresponds to FG. So let's go find FG in it. That one there has got an unknown in it. So that's telling me I can't write a ratio between them to get a scale factor. That's unknown. I need a real number there. All right, let's take a look at these two figures and see if we can prove that they are similar. Okay, so we have two things, or three things really to check. One, do they have the same number size? And they do. One is there corresponding angles that match up correctly, okay? So what I want you to do is just put me on pause, and these are the angles given for this one and the angles given for this one, okay? And I want you to go and place them in the correct place. Remember, across from the largest side is the largest angle. Well, easy enough, I've confirmed that there are corresponding angles that are congruent, that for every 42-degree angle over on the left side, there's a 42-degree angle over on the right-hand side. So I've checked that. Now it's time to check the proportionality of the sides. So I'm going to write a proportion between the sides. I'm going to write ratios between corresponding sides. Now, I have a couple of different ways I could do this. I could go, okay, the side across from the 42 here corresponds to the side across from the 42 over here. So I could write that ratio. I could go 21.6 over 3, okay? And then I would continue to write my ratios of the other corresponding sides. That's one way to determine which side goes with which. The way I like to do it is, if I can do it, if the information is there, is that I know 21.6 is the smallest side over on this triangle. So it has to match up with the smallest side over here. The largest side over here has to match up with the largest side here if we have any hopes of these triangles being similar to each other. So let's just continue to match up. I got 28.8 over the next largest side over on the right of 4. And then we're going to check to see if that's equal to 36 on the left over 5 on the right. Okay, so we're just looking to see if these are similar. Now there's several ways that you can check this. You're checking to see if these fractions are the same. So you could take each one of these and plug them into a TI or any type of calculator that allows you to reduce your fractions and see if they reduce down to look the same. That's one way. I always find that to be the most complicated way. These next two ways are, I think, the first one is to take and just in the first set, cross multiply them using a calculator. And when I do, I get both 86.4. Then I come over to the next set and I cross multiply there. And I get 144 equals 144. Now this is really important. I'm not worried that these didn't create the same numbers. these two fractions over here created a true situation, 144 equals 144. These two fractions created 84 or 86.4 equals 86.4. And all that's saying is that these two fractions right here are proportional, and then the middle and the last one are proportional. And so I conclude through logic that if the first one is proportional to the second one, and the second one is proportional to the third, then I have to conclude that the first one is proportional to the last one. And I could certainly multiply 21.5 times 5 and 36 times 3 and see if that's true, but I'm just going to skip that step and say I've done enough work that I can tell that those sides are proportional. So that's one way. The second way I think is also kind of easy. It's just a matter of taking each fraction and turning it into a decimal and seeing if those three decimals, or four, depending on how many sides the figure has, and see if all those decimal or all those fractions end up being the same decimal. And when I did that, I found that they all equaled 7.2, same decimal, same number. So you choose which method you want to use. Okay? And actually, knowing them both can be really quick, especially if there's no decimals in these numbers. Cross multiplying, you might find you can do this in your head without a calculator, and that becomes very quick and easy. All right, let's move on. Okay, here's a pentagon, two pentagons that I'm told are similar, similar statements stated at the top. And so now I know that there's corresponding angles are congruent and that the sides are proportional and all that stuff. Okay, so what I see is Z in the left figure and an X and a Y in the right figure. That means that it need to be solved for. That means I need to write an equation. So now watch me write the equation for X. I'm not going to solve for it, but I'm going to let you go and try to figure out how to do ones for the y and the z on your own and figure out what those are. Okay, so I'm just going to simply write the equation. So let me show you what I do. I go looking for a side over here that's got a regular number on it. Well, I'm sorry, we go and find the side that goes with x. So I'm going to start x, and so corresponds to IH, right? So we'll go up here, IH, that's the second and third letters. So we'll go over here to second and third, BC. So let's put a 9 underneath it. And so now I'm going to write another ratio. Now this ratio over here, I need to know both top and bottom numbers, no variables. That will allow me to cross multiply and solve for that x. So now I'm going to go hunting for a side that has a corresponding side over here that matches it, or it has a number. Let's start with KG. KG is the first and the last. That's a 45. So E and A. Do I know E and A over here? No, that's actually an unknown. That'll help me remember that. So when I go write the equation for that, how about this LK? LK is the last two, DE. Oh, there it goes. I have that number. So I'm going to come over here and I'm going to grab that 22.5. The reason I'm putting that on top is because I put the X on top over here. So I grab from this one first and put it on top. So I have to grab from here and put it on top. That's very important, common mistake, okay? Now I'll put 5 down below. Now I just simply cross multiply and solve for that. Okay, so now what I want you to do is go ahead and set up an equation for y doing the same exact kind of move, right? Go find, you already have this set. So this side's already set up for you, right? So now all you got to do is set up the left-hand side with the variable for the y and the variable for the z in those equations, cross multiply and solve for them. All right, and there's the equations. Now, real common mistake here is that when you're doing this equation, you put the z on top. But keep in mind the 22 came from the green shape on top. So the 45 comes from there and it has to go on top to match it, okay? So real common for the z to be put on top and the 45 on the bottom because you're used to putting the variable on the top over here. But that was only because the way I pulled those sides, okay? So just be careful about that. All right, so let's take a quick jab at what the scale factor is. Again, we can grab any two corresponding sides and set it up. So we could do 45 over 10. I'm grabbing that information from down there. 22.5 over 5. That's that one, right? I grabbed two corresponding sides to go with that one. And so on. I could grab any two corresponding sides and write a ratio between them. Now I need to make sure that they're reduced. And in every single case, once I reduce it, it should end up being 9/2. Okay. Now again, we'll talk about this a little bit more. Like, should it be 9/2 or 2/9? And it depends on if the shape is getting larger or smaller. Okay, let's take a look at this simpler one. I'm asking you to find x and the ratio between the perimeters. So to do the ratio between the perimeters, I'm going to have to first find x, right? So what I want you to do is I want you to, like the problem before, set up a proportion, x over its corresponding side, and then find another side that corresponds to it itself, and write those ratios, set them equal to each other, and solve for that x. Then once you have that x, you can find the perimeter of the left one, and that's just adding up the sides. Same thing with the right one, and then write a perimeter ratio between them. Let's call this one A, and this one's B, and I'm not going to do that because I have points A and B. Let's call this one 1 and 2, and so I want you to write the ratio of perimeters of 1 to 2. All right, put me on pause and go ahead and do that calculation. All right, so when I did this, I wrote my equation for x over 8. So I grabbed x, and then I went and found its corresponding side. So AC is the first and last letter. So F and E, it'd be this side here, 8. So that's why it's x over E, or x over 8. And I did the same thing for the other side. I found two sides that correspond, and that they gave me the numbers for it. And then I just solved for x equals 4. Okay, so then I plugged it in. I found the perimeter of perimeter 1, perimeter of perimeter 2. And then I wrote a ratio between them, perimeter 1 over perimeter 2, and that gives me 1/2. Now we had this all along. We had this perimeter ratio all along. So if you take a look at the scale factor, and remember the scale factor is a ratio between any two corresponding sides. So we had 5 over 10, and that reduced to 1/2. So here's a very big idea I need you to remember and emphasize in your notes, whatever you need to do. Ready? That's not it. That the perimeter ratio is equal to the scale factor, S1 over S2. The scale factor is found by writing a ratio between any two corresponding sides, right? And so that scale factor is equal to the perimeter ratio. Now, sometimes we know what the scale factor is, but we don't know what the perimeters are, or vice versa. And having this kind of equation, this understanding, will help. Okay, that's it. Again, write your summary. Sometimes it's helpful to have your student learning map sitting there so you can write your summary. Just write from that. Not necessarily copy the words, but maybe put it in your own words. All right, there you go. And let me zoom in so you can see some of these. They should be pretty quick. Probably the most time you're going to spend is just drawing the information as required. Remember, I'm just going to scroll through this and you put it on pause so you can see it. There you go. Have a good day.